Hello everyone, welcome to my YouTube channel. Hope you guys are doing well. So today I will be discussing about some organic reactions. These are specifically from very important from the viewpoint of JEE mains or NEET exams. So without wasting any time, let's go to our main topic. So first of all, let's see this reaction. Here we get a hydrocarbon having OH groups and it is treated with H plus, that is some kind of acid is inorganic acids is used and heating is provided. So what will be the product? First of all, here H plus is given and H plus is electron deficient. So naturally it will try to attain some electrons and neutralize. And oxygen have two lone pair of electrons. So it will obviously give its lone pairs to the H plus and forms this OH2 plus ion, and obviously or naturally everything tries to get stability like you and me, and these molecules also try to gain extra stability. So and this stability can be gained if the molecule have neutral. Here it becomes a charged species, so it will try to become a neutral species by cleavaging this bond. The OH2, that is the H2, become neutrals, and this part becomes a charged species, which is a 2-degree carbocation. Why it is a 2-degree carbocation? Because this particular carbon is attached to two neighboring carbons directly, so it is a 2-degree carbocations. And the stability of carbocations follows the order 3 degree, 2 degree, 1 degree. And this is because the hyperconjugation effect. uh, I hope I will upload some videos on hyperconjugation and the inductive effect, etc. So, when a carbocation gets a chance to rearrange to form a more stable carbocation, it will do so. Here, the carbocation is 2 degree, and it will always try to form a more stable carbocation, that is 3 degree. So let's see. Here, this is a methyl group, and if this methyl group migrates from this carbon to this carbon, then the corresponding carbon becomes 3-degree carbocation. Let's see here. If this methyl group migrates from here to here, this carbon becomes a 3-degree carbocation, which is comparatively more stable than the 2-degree carbocation, the previous one. So this will obviously form. And as here a proton is or H is present, it will try to neutralize the system by removing as H plus. Sorry, this will be H plus. This will be not only H. This will be H plus. So this bond will break in this manner, and here a double bond will be formed. And these also satisfy the Sergev rule. The Sergev rule also state that the more substituted double bond will be formed. Here the both carbons are more substituted, so this will be the major product. This was our first problem, and let's see our next problem. Let's see. Here also a hydrocarbon is given with formaldehyde, HCHO, a carbonyl compound, and H plus. H plus is always as usual. It is electron deficient, and this is the formaldehyde. The carbon is sp2 hybridized, and the oxygen have the lone pairs. Electron density is more in oxygen, so it will obviously donate this electron to H plus and form OH plus. And due to this type of coordinate type of bond, the electrophilicity of the carbonyl carbon enhances, and this carbon always try to attain some extra electron if someone gives it. So here this pi bond is here the pi bonds, and compared to sigma bond, pi bonds are more loosely bound and comparatively more reactive than sigma bonds. So this pi bond will give its electron to this electron deficient carbon and form this type of compound. Here must be a question: why this pi bond break from this carbon? Why not from this? Because here you can see this carbocation is 3 degree. Why 3 degree? Because this carbon is attached to three neighboring carbons. This, and this. So this is a 3-degree carbocation. And if this bond break in this manner, then here a positive charge will be developed, and this carbon is 2 degrees, so the corresponding carbocation will be 2 degree. And as we know, 2-degree carbocations are less stable than 3-degree, so 3-degree is formed is more preferentially. So here most stable carbocation is formed, that is 3-degree one, and this will be formed. After that, in the medium, H2O is given. We know H2 is a source of H plus and OH minus. So obviously, OH minus, the negative part will attack this carbocation and form OH minus. So we will get this type of products. So that's all for today. These two reaction. Okay, thank you.